Children, it is a next part of the mathematics basic concepts, formula, etc. to score 100% marks in MCQ papers. Now let us discuss about the circle. So what is circle, that you know. Now you know what is O is the center of the circle and OA is the radius. This OD is also radius, OC is also radius, and PQ is a chord. This CD is also chord. So you take radii, which are radii OA, OD, OC are radii, chords, which are chords. PQ, CD are chords, and you know that diameter, CD is a diameter, it is also diameter. This is equals to 2r, diameter is the twice of 2r, and here the chord joins any 2 points on the circle, and radius is a line joining the center and a point on the circle, and the diameter is a chord which passes through the center of the circle, and it is twice of the radius. And also you know about this one. What is it? It is a line passing through the circle. It intersects the circle at 2 points. So this is called what? This is the secant. So you consider it is xy intersect the circle at L and M. So you take secant. What is secant? Xy. Now let us take one more thing. What is it? It is a tangent which touches the circle at only 1 point. So you take, it is a tangent. So let us take, this is a tangent TS. Radii, chord, diameter. These are the concepts that you have learnt in previous classes, 9th, 8th, etc. But the secant and tangent, these are the new concepts of 10th class. Now here, what is secant, what is tangent? Here, you know what is secant. It is a line intersecting a circle in 2 points. So you take that. What is secant? Line intersecting a circle at 2 points. So if there is a question, a line intersecting a circle at 2 points is called secant, they have to recognize. Next, the new thing is tangent. Then what is tangent? Know that tangent is a line which touches the circle in 1 point. It intersects the circle at 1 point. So you take that, a tangent to a circle, or you write. Then what is tangent? A line which intersect the circle at only 1 point. Circle at only 1 point. So you take one more word, point of contact. Point of contact. What is that point of contact? The common point of the tangent and the circle. The common point of the tangent and the circle. Here you know that if TS is a tangent, which is the point of contact, M is the point of contact. Now about the number of tangents from a point to a circle. So you consider a circle and a point. The point may be, so consider it is a center. Point may be inside the circle or on the circle or outside the circle. So the point may be inside the circle or on the circle or outside the circle. Now let us discuss how many tangents can be drawn to the circle from a point inside a circle, on a circle and outside the circle. Now just you think, is it possible to draw from this point to the circle? No tangent can be drawn to a circle from a point lying inside the circle. And is it possible to draw the tangent at a point on the circle? Yes, you can draw a tangent to a circle on a point on the circle. That is, there is one and only one tangent to a circle passing through a point lying on the circle. Here you can't draw, but here you can draw the tangent which passes through the single point on the circle. How many tangents you can draw? Only one tangent. Next, if there is a point outside the circle, consider this is a point outside the circle. How many tangents can be drawn? So you can draw tangent. So two tangents can be drawn. So you note down that first one, no tangent can be drawn to a circle. No tangent can be drawn to a circle from a point lying inside the circle. From a point lying inside a circle. Second, you note down, there is one and only one tangent. One and only one tangent can be drawn on a point or at a point on the circle. Drawn at a point on the circle. Next, third one, exactly two tangents can be drawn to a circle from a point lying outside the circle, right? Two tangents can be drawn to a circle from a point lying outside the circle. From a point lying outside the circle. So here question may be asked, how many tangents can be drawn from a point inside a circle, from a point on the circle and from a point outside the circle? You must know this. So for the multiple choice question, they can ask about the number of tangents that can be drawn from a point to the circle. Next, also you know that the length of the tangents drawn from an external point. Here it is said that lying outside the center means, outside the circle means that is the external point. External point. Now how many tangents can be drawn? Here two tangents can be drawn from the external point. And one more thing you can observe, they are equal. The length of tangents, the length of tangents means two tangents, both the tangent drawn from an external point external point means point outside the circle, external point to a circle are equal. Now let us discuss about the relation between the tangent and the radius at the point of contact. Now you take the circle with center O and the tangent at a point. So consider it is a tangent at P. Consider AB is a tangent. Now if you join this P point of contact to the center, so you will get a radius. That is what? Radius. Then what is the measurement of the angle here? That is 90 degree. So here OP is perpendicular to AB. OP is perpendicular to AB. So you can say that the radius at the point of contact is perpendicular to the tangent. So write radius at the point of contact of a tangent is perpendicular to the tangent. So it is one of the important concept. The angle between the tangent and the radius at the point of contact of the tangent is equals to what? 90 degree. That is angle OPB equals 90 degree. Angle OPB equals 90 degree. And there may be some questions based on this concept. Now consider here a circle and a diameter, and you know that you can draw the tangent at the ends of the diameter, and the tangents drawn at the ends of a diameter of a circle are parallel. Here these two tangents are parallel to each other. So that is one of the next concept. You take the tangents drawn at the ends of a diameter of a circle are parallel. Diameter of a circle are parallel. If you consider AB and CD are tangent, you know that if they touches the circle at a point P and Q are the point of contact. You know the measurement of these angles. The four angles are 90 degree, and AB parallel to CD. AB parallel to CD. That is one of the important concept. One more thing you can observe here. The perpendicular at the point of contact to the tangent. Perpendicular to the tangent at the point of contact passes through the center. Same thing you can say here. If you draw the perpendicular at the point of contact, that perpendicular passes through the center. That also you can note down here. So write the perpendicular at the point of contact point of contact, the perpendicular at the point of contact to the tangent to a circle passes through the center. How many parallel tangents can have the circle at the most? A circle can have two parallel tangents at the most. A circle can have two parallel tangents at the most. Here the pair of parallel tangents can be infinite number, but for one tangent only other one tangent will be parallel. So you can have two parallel tangents at the most. So right, a circle can have two parallel tangents at the most. But it can have infinite number of set of parallel tangents. Then also here one more thing you can observe here. Consider a circle and this is the center. This is the external point. Now you consider this is a external point T. From this T, A and B are the point of contacts of the tangents AT and BT. Now one more tangent is there. That is, let us take PQ. Now here there is a triangle TPQ. And you know that the perimeter of the triangle is TPQ is TP plus TQ plus PQ. And there is a relation here, perimeter, that is PT plus PQ plus QT is equals to what? 2 into AT or equals to 2 into BT. That you have to keep in your mind. Here multiple choice questions will be there. So they will give the perimeter of the triangle and also they will ask the length of AT or length of BT. In that case, you know that AT is equals to half of perimeter of triangle PTQ. Half into perimeter of triangle PTQ, or also if they ask BT is also equals to half into perimeter of triangle PTQ. How it will be? You know that here if you take this is the point X, these two are equal, these two are equal. This AT and BT are equal, they are the tangents from the external point, and also this is equals to this one and this is equals to this one. So if you take the perimeter, so that becomes PT plus TQ plus QX plus PX. In the place of these two, you can take these two. So that becomes what? AT plus BT it becomes. That is nothing but 2AT or 2BT, because AT and BT are same. So whatever it may be, you keep in your mind that the perimeter of this triangle is twice of the tangent or the sum of the tangent. So if the perimeter is given, half of the perimeter becomes the length of the tangent. Half of the perimeter is the length of the tangent. That you have to keep in your mind. For example, here the perimeter is 30 centimeter. Then AT equals what? Half of 30, 15 centimeter. Or what is BT equals 15 centimeter. So this type of question will be asked in the MCQ type paper. That is, perimeter will be given and length of the tangent will be asked, or length of the tangent will be given, perimeter of the triangle will be asked. If the length of the tangent is given, twice of that length becomes the perimeter of the triangle. That is, if 15 is given, you must double it. That is one of the important property. And one more thing you can consider here. Consider a circle with center O, and here is the external point, and these two are the tangents from the external point. And also you know that here this is the radius, this is also radius, and this is O, and it is P. PA and PB are the tangents. And if you draw the line by joining O and P, these two angles are equal, and these two angles are also equal. That you have to keep in your mind. Here, angle at the center made by the line joining the center and the external point are equal. These two are equal, and also these two are equal. That is, angle AOP equals angle BOP, and also angle APO equals angle BPO. These two are having, for example, if it is 30, this is also 30. Then what is the measurement of this angle? This is 90. Then what is the measurement of this angle? 90 plus 30 is 120. 180 minus 120, you will get 60. Or otherwise, directly subtract this angle from 90, because this is naturally 90. So you subtract the 30 degree by 90, you will get 60. So it is very simple. For example, the angle AOP equals 70 degree. What is the measurement of this angle? So directly you subtract this 70 degree from 90, you will get 20 degree. Or this angle is given, this you will get again 20 degree. So they are the equal angle. Or one more thing that you can observe here, the sum of these two angles is equals to how much? 180 degree. If that middle line is not there, if this line is not there, then what you can have, the sum of these two will be equals to 180 degree. Then if one angle is given, to get the other angle, you must subtract that given angle by the 180 degree. Because you know that these two angles are 90 degree, that sum is 180 degree. And here it is APBO. This APBO is a quadrilateral. In the quadrilateral, sum of all the four angles is equals to 360 degree. Therefore, here if this angle is given, to find this angle, what you have to do? Subtract that angle by 180 degree. If this angle is given, to this find this angle also, you have to subtract the given angle by the 180 degree. So here you are subtracting from 90 degree. Here you subtract from 180 degree. So for example, it is, again you take, this is 140 degree. What is the measurement of this angle? 180 minus 140 is 40 degree. Or if this angle is given, let us take one more example. If this is 60 degree, what is the measurement of this angle? This is 120 degree. The sum of these two is equals to 180 degree. These are the basic concepts that you have to use. Now you observe one more important concept. Consider here ABCD is a quadrilateral. What is ABCD? ABCD is a quadrilateral. Know that AB, BC, CD and D are the tangents of the circle with center O. Now here one thing you can observe, AB plus CD. AB plus CD equals AD plus BC. AD plus BC. That is one of the important concept, because here these two parts are equal, these two parts are equal, again these two parts are equal, and again these two parts are equal. So by using that property, you will get this one. Here proof is not required, but this is one of the concept you keep in your mind while solving the MCQ in your question paper. Here, if the sum of these two sides are given, the sum of these two sides are also same. The sum of the opposite sides are equal here. Here, if what are given, if the sum of this and this, AB and CD are given, the same sum is for the other two sides are also. If the sides of the quadrilateral are the tangents to the circle, then the sum of their opposite sides are equal. Sum of the opposite sides are equal. So you can use this concept while solving the multiple choice question. Now you observe one more situation. Here P is an external point and two circles are there. They are internally touching circle. C is their point of contact. Here C is the point of contact of the two circles which touches each other. Now here tangents are drawn from the point P to the circle. Here you observe PC and PB are the tangents to the smaller circle with center. You take O1, and here PC and P are the tangents to the circle with center O2, that is the bigger circle. Now what about the measurement of the tangents? They all are equal. You know that if this is 8 cm, this is also 8 cm, this is also 8 cm. Here they will give the length of this one and ask the length of this one. Then how will you find that length? Here you know that these two are equal and these two are equal. So all these three are equal. If one measurement is given, then all the measurements are having same measurement. All are having same measurement. That you have to keep in your mind. This is also one of the important concept that. So come to one more situation. See the figure here. This is a circle with center O. Circle with center O. AP and BP are the tangents from the external point P. And they will give the length of tangent. Consider here this is 7 cm. And they will give the measurement of this angle. So if they give 60 degree, then they will ask the measurement of AB. In this situation, what you have to do? Here, this is 60 means this is also 60. Because these two are equal, angles opposed to the equal sides. Then what is the measurement of this angle? That is 60. So it is an equilateral triangle. So this is also 7 cm. So here, if one angle and the length of the tangent are given, then you will get the measurement of the chord. And also you know that the tangent subtend equal angle at the chord. Tangent subtend equal angle at the chord. So you take here these two are equal, and if you take the triangle, angles opposite to the equal sides are equal. Angles opposite to the equal sides are equal, as these two sides are equal. They are the tangents from the external point. You know that here B is a point of contact and A is a point of contact. If you join AB, you will get a chord. And the angle at A and B are equal because they are the angles opposite to the equal sides. There may be question like this way. Here the circle will be given and tangent will be given. And the length of the OP and PR is given. How will you get the length of OR? Here you know that this is 90 degree. The angle between the tangent and the radius at the point of contact is 90 degree. So you apply the Pythagoras theorem. That is OR square equals 4 square plus 3 square. Then OR square equals 16 plus 9 equals 25. So OR equals what? Square root of 25, that is equals to 5. In this way, by using the Pythagoras theorem, get the measurement of the unknown. That is, the concept used is here, OP is perpendicular to the tangent AB. In this way, by using all these concepts, you can easily solve the multiple choice questions.